Okay, assalamualaikum everyone. Alright, now we will continue with the next case. Okay, for case 2 we have solving partial fraction when gx is a product of repeated linear factors. Okay, so we have two keywords, that is, it is repeated and it is the linear factors. Okay, so the steps that we will follow here, we have three steps. The first one, we will set up the partial decomposition. Okay, so the partial decomposition for this case is this one. Okay, if we have fx over ax plus b to the power of n. Okay, so look at here, we have power of n. That means it is repeated. Okay, the factor is repeated. Then your partial decomposition will be a over ax plus b plus b over ax plus b square, and then until it depends on how many repeated factors that you have, and it will be plus n over ax plus b to the power of n. Alright, if you have 3, then it will be power of 3. If you have power of 4, then you will repeat, or your partial decomposition will be until the power of 4. So it depends on your questions. Alright, next, the second step, we will find the value of a and b. Okay, and lastly, you will solve the integration. Alright. Okay, let's see for the example. So we have here solve the following integration. Alright, the first one we have here is integrate 6x plus 4 over x times x minus 1 squared dx. Okay, firstly, you have to identify the types of your function. So it is a rational function. Okay, rational function, and it is a proper rational function. Alright, continue next. We have to identify the denominator. So since it is written in the form of factors, so we say that gx can be factorized. Okay, so next, if gx can be factorized, we have to use partial fractions. Alright, so for partial fractions, we have 3 cases, so you have to identify which case is suitable for your partial fraction. So in this case, let's see here, we have this one, it is a linear, right? Okay, the second one here, we have the power here. So look at here, we have the power of 2. Okay, that means, and inside the bracket, it is a linear factors where your x is power of 1. So we see that this one is repeated linear. Okay, that means in this case, you have the combination of case 1 and case 2. So it is case 1 and 2. Okay, so let's look at the partial fraction. Alright, so for the partial fractions, okay, we have here 6x plus 4 divided by x minus 1 square. So the partial decomposition will be a over x for the linear, okay, for the linear factor, and then plus with, for the repeated linear factors, it will be b over x minus 1. So we will put the first, the linear factor with the power of 1 first. Okay, so power 1 first, and then plus c over x minus 1 square. Okay, so this is for the case 1 for the linear factor. Okay, or I just put case 1. And for this one, it is for case 2. Okay, so the partial decomposition is following the case 2. Alright, so with the similar steps as before, okay, before this we have learned, the next step is we will write the equal denominator. Okay, so write the equal denominator. And we will have here is x minus 1 square, and this one is 6x plus 4. And similarly for the right hand side, your equal denominator is this one, x minus 1 square. Make sure the denominator is similar as in your left hand side. Okay, so the denominator in left hand side equals with your denominator in your right hand side. Okay, continue. What will be your numerator? Okay, so since you have you want to write the denominator is in the form of x times x minus 1 square, that means for a here you have to multiply with x minus 1 square. So this one you have to multiply with x minus 1 square. Right? So for b, the other factor that you have to multiply is x and another x minus 1. Right, so x times x minus 1, it will combine as x minus 1 square. So this one you will multiply by x minus 1. And for this one, you only have to multiply by x as well as this one. Right, so now your numerator will be a times x minus 1 square plus b times x minus 1 plus c times x. Okay, so next step, we will cancel off the denominator, and the remaining function we have here is 6x plus 4 equals to ax minus 1 square plus b x minus 1 plus c x. Okay, alright, so next step is we want to find the value of a, b and c. So we want to find a, b and c. Okay, we can use the substitution of x. Alright, so let's say if you want to eliminate your x, you will use x equals to 0. If you want to eliminate x minus 1 here, you will use x equals to 1. And we have another one problem, because for a, okay, it is the x minus 1 square. It is a repeated linear factor. So later on we will see how to solve for a. Okay, so firstly we will start with substituting your x is 1. So substitute x is 1. Alright, and we will have 6 times 1 plus 4 equals to, so this one you will get a 1 minus 1 square. So this one it will get 0. Okay, and then we have here b. So this one 1 minus 1 plus c times 1. And when you simplify, you will get 6 plus 4 is 10. So this one will be 0, and this one is also 0. And for c, you have plus c. That means your answer for c is 10. Continue, substitute your x equals to 0. Okay, you will have your 6 times 0 plus 4 is a 0 minus 1 square plus this one you will get 0, and also for c you will get 0. So you have here 4 and negative 1 square. Okay, let's say if I put negative 1 square, okay, you will have your a is 4. Okay, alright, for the third one, for to find b, you don't have any other factor that you can eliminate, right? So what you can do is you can substitute any value of x and together with b, and together you have to substitute your a and c. Okay, so for the third one, substitute x. Okay, you can choose any value of x. Let's say we choose x equals to 2, for example. Okay, and then also you have to substitute your a equals to 4 and your c equals to 10. Substitute x equals to 2, a equals to 4, and c equals to 10. So you will get it is 6 times 2 plus 4 equals to, so your a is 4, 2 minus 1 square plus b, you have to find b, and your x is 2 minus 1 plus, and your c is 10 times 2. Okay, then you will simplify. Okay, and you will get b is negative 4. Okay, class? Alright, so now finally, what will be the integration? So let's see. So you want to find the integration of 6x plus 4 over x minus 1 square. Okay, alright. So lastly, now you will have the integration of 6x plus 4 over, so x minus 1 square dx, it will be equals to the integration of, so what is your a? 4 over x, alright? Okay, firstly 4 over x, and then b over x minus 1, and c over x minus 1 square. So your b is negative 4, so minus 4 over x minus 1, alright? And then your c is 10 plus 10 over x minus 1 square dx. Okay, and lastly, what will be your answer? Yes, your answer is 4 ln x minus 4 ln x minus 1 minus 10 over x minus 1 plus c. Okay, can you remember how to integrate this one? How? Yes, you have to use U-Substitution. Okay, so please refer to your warm-up exercise that I have given you in the first class. Okay, please remember to integrate 10 over x minus 1 square. You need to use U-Substitution, and the answer will be this one, negative 10 over x minus 1 plus c. Okay, class? Alright. Okay, let's see for the second example. Okay, we have here the integration of 2x squared plus 3x plus 2 over x squared times x plus 1 dx. Okay, firstly, as usual, we will identify the types of your function. We have here is a rational function. Okay, and then it is a proper rational function. Okay, so be careful, class. We have here, this one is the highest power of x, and your numerator is x squared, and the highest power of x in your denominator is x power 3. That is, when you expand, it will be x power 3. Okay, so be careful when you identify your function. Alright, and then continue for proper rational function. We will see the denominator. So denominator here, you can factorize it. So it can be factorized. And we will simplify by using partial fraction. Okay, good. Okay, next we want to identify which case is for your partial fraction. So let's see here. We have here is x squared. Okay, look at here. We have square here, power of 2. Okay, that means the first one is repeated linear. Okay, repeated linear factor, that is case 2. Okay, x a factor x times x. Okay, x times x. So you have repeated linear factors. Alright, so another one and another one we have here is x plus 2. This one is for linear, distinct linear. That means it is a combination of case 2 and case 1. Alright, okay, let's proceed with the partial fractions. Okay, now your partial fractions will be 2x squared plus 3x plus 2 divide by x squared x plus 1. Okay, firstly, when you set up the partial decomposition, we will have a over x plus b over x squared. Okay, and then plus c over x plus 1. Okay, that means we have here, this one is for the repeated or for case 2. Alright, and this one is for case 1. Okay, again, please remember, if you have the factor in the form of power, that means it is the case 2, the repeated linear factors. Okay, and you will have, for the partial decomposition, we have 2 terms. Okay, a over x plus b over x squared. Okay, alright, next let's continue. We will write the equals denominator. Okay, so we have here x squared x plus 1. This one 2x squared plus 3x plus 2. Okay, so you will get here, it is with the same denominator as your left hand side, and we have here x squared x plus 1. Okay, and what about your numerator? Yes, the numerator will be now is a times x and x plus 1. Okay, so let's look at here. So in the first one we have only x. Okay, to make it as x squared times x plus 1, you have to multiply with another x and x plus 1. As well as for your numerator, you will multiply with x and x plus 1. Okay, so for b, okay, you have to multiply only with x plus 1 because you have the x squared over there. So we have another x plus 1 here, and for c it is x and x plus 1. Sorry, it will be x squared only. Okay, you have just multiply with x squared. Sorry. Okay, alright, so now we have for b, it will be plus b times x plus 1 only, and then plus c times x squared. Okay, class? Alright. Okay, next step, we will cancel off the denominator, and the remaining function we have here is 2x squared plus 3x plus 2 equals to ax x minus 1 plus b x plus 1 plus c x squared. Okay, so next step is we can eliminate the factors. Okay, one or two of the factors here. We can substitute firstly your x equals to 0. Okay, for this one, for this factor you can substitute, sorry, not this one. We can only eliminate for the linear factor. So for x here, you will substitute as x equals to 0 on, and for this one you can substitute your x equals to -1. Okay, now let's continue. Substitute your x equals to 0, and we will have 2 times 0 squared plus 3 times 0 plus 2 equals to, for this one you will get 0, plus, so for b you will get 0 plus 1, and for c you will get 0. Okay, simplify, you will get 2 will be equals to b, and we will say that your b equals to 2. Okay, continue next. Substitute your x equals to -1. Okay, and we will have 2 times -1 square plus 3 times -1 plus 2 equal to, so this one also will be 0, and plus for b is also 0, and for c we have -1 square. Okay, now we will have here, it is 2 minus 3 -1 plus 2 is 1 equals to c. So we say that c equals to 1. Okay, now how you want to find your a? Okay, so one of the method that I've given you before this, okay, from the previous example, is we can substitute any value of x, and together we will substitute your b and c. Okay, so we have another method, that is you can use comparing coefficient. Okay, so let's see how to use the comparing coefficient. Okay, to use the comparing coefficients, we don't have to substitute the value of x, okay, but we need to substitute the value of b and c in your equation here. Okay, so substitute b equals to 2 and c equals to 1. So you will have now your equation will be 2x squared plus 3x plus 2 equal to, so a x plus 1, okay, plus your b is 2, okay, x plus 1 plus your c is 1, x squared. Okay, so this is the functions that you have after you have substitute your b and c. Okay, alright. Okay, next, by using comparing coefficient, we will expand, okay, expand your right hand side. 2x squared plus 3x plus 2 will remain the same. Okay, we just expand the right hand side. Okay, do not solve this equation, just expand. Alright, expand your right hand side. So when we expand, we will have here is a x squared plus x plus 2x plus 2 plus x squared, and then you will get this one is ax squared plus ax plus 2x plus 2 plus x squared. Okay, next step is we will collect the coefficient for each terms. Okay, that is, the first term is for x squared. Okay, when you collect for x squared, you will have here is a plus 1 x squared, okay, plus a plus 2 x plus 2. Okay, and your left hand side, it will be 2x squared plus 3x plus 2. Okay, comparing coefficients means we will compare the coefficient for each terms from the left hand side and the right hand side. Meaning here, so we have here for x squared. Okay, so this is the coefficient that we will compare. Alright, and then we have for x. Okay, we will compare this one. Okay, and last one for number. So look at here, you will get the same number. Okay, you have here 2, and also in your left hand side you have 2. So in case if you have different number, that means you will you need to simplify, or you need to check first from the beginning. Okay, alright, so now when you compare the coefficient for x squared, okay, the coefficient is 2 equals to a plus 1. That means what will be your a? So your a will be equals to 1. for x power 1, okay, you have the coefficient is 3 equals to a plus 2. That means your a is 1. Okay, so look at here. For both x squared and x power 1, you will get the similar a here. Okay, that means your a is equals to 1. Okay, so now what will be your final answer? Okay, so we want to find the integration of the question. Here we have 2x squared plus 3x plus 2 over x squared x plus 1. And you will get it is equal to the integration of 1 over x plus 2 over x squared plus 1 over x plus 1 dx. Alright, so now we can integrate. It will be ln x minus 2 over x plus ln x plus 1 plus c. Okay, so please remember how to integrate this one. It will be the integration of x power negative 2 dx. It will be 2x negative 1 over negative 1. Okay, that's why you will get it is negative 2 over x. Okay class, so this is your final answer.